Alright, so like I said, guys, this week, looking at, still doing systems of equations, but we're doing word problems with them. You guys remember when we already did one in the warm-up. What is a system of equations? Who remembers? Who can tell me by raising their hand? System of equations. One problem, two problems, one equation, two equations, 7 equations, 352 equations. What is it? Wake up, guys. I know it's Monday morning, but wake up. What's a system of equations? Who can tell me? We just did one in the warm-up.
How many letters are you solving for? Two.
Right? 2 letters. All right. How many problems do you have? 2, right? That's a system of equations. All right. You got 2 equations with 2 variables. 3x plus y equals 6. 7x plus 3y equals 7. All right. That's an example. I'm not gonna. The next thing I ask you guys to come up with an example. All right. I just talked about that. I'm not gonna write one down. Plus, we did a couple on the warm up. All right. So far, we've used 3 methods to solve systems. All right, Victor, you said, what is it? Substitution's one. What's another one? Elimination. Anybody remember that last one? Graphing. Right. Those are the 3 kinds that we've talked about so far. Graphing, substitution, elimination. All right. Like Mr. Hager just said. Like Mr. Hager just talked about. All right. Today we'll solve systems word problems. All right. They're going to involve age. And we're going to solve them using the substitute. Every word problem we do this week, we're going to use substitution to solve. All right? Just like last week, we're going to have a template. The template's going to be a little bit different than what we used last week for elimination, but I think it's going to help you guys to keep your stuff a little bit organized. All right? So we'll use substitution. Everything else in? All right. Let's just look at some of the phrases we're going to see. So let's say, Mr. Hager and I are telling you right now, we're going to let T equals Tim's age. So wherever you see Tim's age, we're going to put the letter T. All right? Write an equation that represents Tim's age in 6 years from now. What would I write? Who can tell me? How would I represent an equation that represents Tim's age in 6 years from now? Ryan?
T equals 6.
Not T equals 6. T plus 6. All right? When you see in years from now, that means you're going to add, right? You're going to the future, right? You have to add. So it's going to be T plus 6. We're telling you that T, all right, we're giving you how you're going to represent Tim's age. You're going to add 6 to it. All right? Now, let's write an expression that represents Tim's age 4 years ago.
T minus 4.
T minus 4. Good, Logan. T minus 4. Years ago, subtract. In a certain amount of years, you're going to add. All right? That's one big thing you have to take away from this. All right? And I like how Ryan set his up where he put the variable first. That's good. And he won't make any mistakes that way. Let's look at something else. Same kind of thing. We got Ryan's age now. All right, so R is going to be Ryan's age now. How are we going to write an expression of how old Ryan will be in 4 years? Who can tell me? Alexis, what do you think? How would I write an expression for Ryan's age in 4 years? We're going to the future, right? What letter am I going to start with? R, okay. Not times. What do you think, Gage? R plus 4. Remember, if it's in a certain amount of years, we'll go into the future. We're going to add. All right? In a certain amount of years, we're always adding. All right?
What if it said, like, how old will you be in 2 years? So if you're 15 now, would you double it and say, oh, in 2 years I'll be 30? No. Right? You just add 2 to it and say, oh, in 2 years I'll be 17. Okay.
This one. Davin, how do you think you'd represent Ryan's age or write an expression for Ryan's age 8 years ago? Perfect. R minus 8. So, if we have years, someone tell me by raising their hand. If we have years ago, what are we going to do? Someone tell me, raise your hand. Anybody? Kevin. Years ago, you're going to subtract. However many years ago it says, you're going to take the variable and subtract. What about in a certain amount of years? What are you going to do? Add, right? Years ago, all right, subtract in a certain amount of years, you're going to add. All right, let me quickly give you guys the notes. Guys, I'm trying a little bit something different today. Instead of giving you like step-by-step notes, what we're going to do is we're going to do one example together. And what we'll do is we'll put the notes right on that example. So you have one example that shows you how to do it with all the steps. All right? That's what we're going to do. All right? So I think with this stuff, I think I might make a little bit more sense rather than writing out step by step, in order. I think it'll help you guys. Like I said, the first one you see, don't freak out. You guys did pretty well with that review stuff. All right? Rosie, make sure you're taking these notes today. Mm-hmm. No love letters. And I'm a good-looking guy, but jeez.
What?
All right. So, just like last week, guys. This is the template that we're going to use. A little bit different than what we use for elimination. All right. But obviously, when we're doing these, we're going to have people's names. We're going to have, because it's a system of equations, we're going to have to set up two equations. All right. We're going to have to use some substitution. Once I go through it, it'll make more sense. But this is what it looks like. Right? And once you get to this last part, you'll see there's directions down here that kind of make it pretty self-explanatory. Once you get to that point. All right? Let's see here. So, Paul is 3 times as old as Kathy. In 8 years, he'll be twice as old as she will be. How old is each now? All right. First thing we want to do, under this name column, first thing you're going to do is, number 1, write names from the problem. All right, so the first thing we're going to do is we're going to write out that arrow that's all the way on the left, the furthest one. What's up, Lauren? I don't right now, buddy. Sorry. I can't pull one out of thin air.
Mr. Hager.
Sorry, I don't know what I did here, buddy. I'm sorry. I don't know what I did. There we go. All right, so I'm going to write my names right here. Where it says name, I'm going to write the names in there from the problem. Someone can tell me what's one of our names from the problem? Paul. Good, Corey? Paul's one. And Kathy. Good. All right, so we already did the first step. Paul and Kathy. Number 2, second thing, in here. All right, so you're going to use the first letter of the name as your single variable. All right, so the first letter of each name, all you're going to put in there is a single variable. That's it. That's all you're going to do. All right, so my single variable for Paul will be what? P. And what about for Kathy? C. That's all I'm putting in. That's all I'm putting in there. All right, use the first letter of name as a single variable. So P and C. So you're going to see in a second when I set up my first equation down here, wherever I see Paul's name, I'm going to put a P. Wherever I see Kathy's name, I'm going to put a C. All right? Whenever I see their names come up, I'm going to put a P or a C. All right? And that's going to be my third step down the bottom here. All right? This is going to be your first sentence. All right? The first sentence in the problem, that's how you're going to set up this equation. All right? All right? So any information that we get to set up this equation it's going to come from the first sentence in the problem. Every problem we do this week that's an age problem, Mr. Hager and I will make sure that the first sentence will be your first equation. We're not going to switch it around, right? Your first sentence will always be your first equation. And it's always going to have the single variables. All right? So let's go back up to our first sentence. What's the first thing we see? What's the first thing we see in that first sentence?
3 times.
No, the first thing we see, the first word written there. Paul. What am I going to put? P, right? Wherever I see P, wherever I see Paul, I'm going to put the letter P. All right? P. Paul is P. All right? P. I'm going to put the P in the circle down here. Is is a key word, right? What's it mean? Equal, right? I talked about that in the warm-up. Look at, every time you do these, your equal sign's already going to be there. So P equals is 3 times 3. What's 3? Just 3. Put the letter 3. I mean, not letter 3. Put the number 3. Put the number 3 there. 3 times as old. No, next one, Morgan. 3 times as old as Kathy. I see the name Kathy. What am I going to put?
C.
C. Wherever I see these people's names, Paul or Kathy. Paul for the first equation is going to be P. Kathy for the first equation is going to be C. First equation is done. All done. That's it for the first equation. We got a couple more things we got to do. All right, that was our third step. Let's look at our fourth step. We're going to add or subtract the single variable, depending on what we get for a phrase in that second sentence. All right? We're going to add we'll add if it says in a number of years, in 2 years, in 5 years, in 6 years. If it says that, we'll take the single variable that we have for that person and add a number to it. All right? If it will subtract, if it says number of years ago. If it says a number of years ago, 6 years ago, 3 years ago, 10 years ago. If we see that, we're going to have to subtract from the single variable. So in this problem, it says in 8 years. So what does that mean I have to do to the single variables? It says in 8 years. I'm going to add, right? Up here, as my title or my heading, I'm just going to put plus 8. Because it says in 8 years. So I'm going to add 8. I'm going to take each single variable and add 8 to it. Paul will become P plus 8. Kathy will become C plus 8. That's it. That's it for that part. All right? I'll wait till you guys get this down. If it said 5 years ago, minus 5. 2 years ago, minus 2. All right? To each variable. Now, last step in terms of setting it up. I'll leave that up there. If you guys don't have that yet, you can get it. All right? Last thing. This is going to be your second sentence. All right, now we're going to use the information from row 2 to set up the equation. This is where it gets a little tricky, because when we're talking about that second sentence, we're either going to the future or we're in the past. But if we see right now, wherever I see Paul in that second sentence, or if it says he, Paul is now going to be P plus 8, because it's in 8 years. If I see Kathy, or she, or her, she becomes C plus 8. Because the first one we set up is always in the present. All right? The second one that we set up is either going to be in the past or in the future, depending on what the first phrase is in that second sentence. So let's go back up and look. So wherever I see these people's name now, Paul's P plus 8, Kathy is C plus 8. All right? So, in 8 years, he, who's he? Paul. But we're talking about Paul in 8 years. So what am I going to put? P plus 8. Paul is now P plus 8. All right? Because we're in the future now. So P plus 8. What's the next key word up there?
Twice.
Not yet. You skipped one. Will be, right? What's will be mean? Talked about it in the warm-up. Is, was, will be all mean equal. Is, was, will be all mean equal. All right? Twice. What number should I put? 2. Twice as old as she. Who's she? Kathy. What's Kathy? But we're talking about Kathy 8 years from now. So what do I put? C plus 8. Should I put anything else with that? That might be helpful for us. I'm going to put parentheses around that. Bang. That's my second equation in the future, all set up. This is where it gets tricky, because when I say use the information from row 2, there's your information from row 2. P plus 8, C plus 8. Wherever you see those people's names, Paul or Kathy, or whoever person you're dealing with, you're going to put that. Not just P, you're going to make sure you apply if it's the future or the past. All right? Now, I'm going to scroll down because we got everything we need now. We're pretty much all done with the problem. We pulled everything out, all the information out of the problem that we need. All right? Now, it says work area to solve. This is going to be on there when you take your test. It'll be there on there all week. Work area to solve using substitution. I'm going to take the row 2 equation with parentheses so whatever letter is in the circle, you're going to substitute what's in parentheses for that letter. So in this equation, what letter am I substituting for? So I'm going to do all my work to this equation right here. I don't want 2 variables. I only want 1. So what variable am I substituting for? P, right? I'm substituting for P in this problem. Here's P. What am I substituting for P? What's P becoming? 3C. All right? I'm taking this, plugging it in for P. All right? So, whenever letter is circled here, I'm taking the information in the parentheses, plug it in for that letter in the other equation. So, my new equation is going to be 3C plus 8 equals 2C plus 8. I'm good because I only have 1 variable. If you had a P and a C there, you're wrong. You can only solve for 1 equation. 1 variable. So that's why I had to do the substitution. All right? So now, in this problem, right here, what would be the first thing I would do? Anybody know? Distribute, right? So I'm just going to bring this stuff down. The 3C plus 8, I'm just going to bring down. I can't combine these things. The 8 doesn't have a C, and the 3 is not just a 3. It's got the C attached. When I distribute, what am I going to get? Yep. Plus 16. Remember, I'm multiplying there. 2C plus 16. Can I combine like terms? No, not on the same side, right? Nothing's the same. What am I gonna do now? What do we wanna move first? The letters or numbers? Wanna move the letters first? All right, Zach, which one do you wanna move? How you gonna do it? Subtract. Remember, to move something, give it the opposite sign. The opposite sign is like it's taken to the other side. So it can match up. It's gonna match up with its buddy on the other side. Zach, when I do that, what am I left with? 3C minus 2C. Just C, yeah. I'm gonna leave it as C. If you put 1C, you're not wrong. The good thing about this is, all right, there's gonna be no division because there's no number attached to this. Plus 8 equals 16. All right, one more step and I'm done this part. Who knows? Jalen, you know? It's my last step. Subtract 8. Good. So subtract 8 here. What other number am I subtracting 8 from? 16. Perfect. C equals 16 minus, not dividing. 8. C equals 8. All right. Now we got C equals 8. Now I got to go back. This is when it gets a little tricky. Now I got to go back to my, like it says here, substitute letter you solve for into row 1 equation. Here's my row 1 equation. P equals 3C. It's not going to work because I got 2 different variables. I got a P, I got a C. I can't solve. What letter did I just solve for? What letter did I just solve for? C, right? I want to write this equation now with the letter I just solved for. I want to plug in a number for it. I didn't solve for P, right? P equals 3. What did I get for C? 8. I'm plugging in for 8. P equals 3 times 8, 24. All right? So like I said, you got to go through, pull everything out of the problem to set up your chart. All right? Once you go through set up your chart, you're going to substitute twice. You're going to substitute the information from the row 1 equation into row 2. Once you solve for that letter, you'll plug it back in to row 1. You're working back and forth. All right? But the hardest thing with this is, guys, making sure that you set it up, making sure you pull out the right information to solve. All right? Why don't you guys...
Mr. White, why don't we do one more together?
Okay.
And then let them do one.
Okay.
I think we'll probably only get to 3.
Okay.
Yeah.
Let's give them maybe a couple minutes or so, and let's see if they can set up the box. Then we'll solve together. Is that fair?
All right. So try example 2.
Yeah.
Okay. See if you can pick out the names.
Yeah.
See if you can figure out what the letters are.
Yeah.
And then see if you can figure out, are they talking about how old they're going to be in the future? So should it be plus a number? Or are they talking about the past? Should it be minus a number? Okay, so just take a minute and set up the table.
Yeah, we're not looking, don't worry about solving or anything like that, or even like going into substitute yet. All Mr. Hager and I are looking for right now is if you guys can set up just a box.
All right, so let's start, take a look, see if we can set up our table first. Somebody tell me the 2 names that we're going to use in this problem.
Pete and Heather.
Right. So I'm going to put those in right under where it says name. Pete, Heather. Okay. What's the next thing in that table I should fill in? Alex?
The variable.
Yeah, we're going to fill in the single variable.
Looks like most people had that too, Mr. Hager. At least that first row. That's a good start.
So, Alex, what did you use for P?
Just P.
P? That works. And how about for Heather? H. Sure. All right. Now for row 2, you have to look and say, is this a problem about the future? Or is this a problem that says like years ago? Okay. Which one is this? Is it talking about their ages in the future or the past? In what? Yeah, in the future. In 6 years. Okay? So we want to think what our heading would be. How would you figure out, like if you knew your age right now, what would you do to that number to figure it out in 6 years?
Add 6.
Add 6. All right. So now I want to do that to both Pete's age and Heather's age. How old is Pete in 6 years from now? P plus 6. And how old would Heather be 6 years from now? Yeah, good job, Justin. H plus 6. Okay, so that's all the information about their ages. Now we have to start looking at making the equations. Okay, questions on that step?
Looks like most people had that mistake.
Got that?
I walked around.
All right, it says Pete is 5 times as old as Heather. Right? Anybody have a thought how we can start to set that up? Or at least what variable is by itself on the left? Pete is. Right, so Kevin, what letter do you think is by itself on the left? Whose name starts the equation?
Kev,
P. Okay, so
Kev,
P.
for that first equation, where do you get the information? Where do you get the information? So obviously you're going to use those letters, the P and the H, right? But to set the actual equation, where do you get like the order of like the numbers and the letters and stuff like that? First sentence, good.
Right, so it says Pete is. Okay, what comes next, Rose?
I put 5H.
Yeah, Pete is 5 times Heather. 5 times as old as Heather. So Rose, that was perfect. 5H. All right, so that's one equation we have to set up. Now I got to set up one more. Okay, this is going to be about their ages in the future. So now in this second equation, anytime you see Pete or his or him, Pete's no longer P. In the future, he's no longer P. He's P plus 6. Okay? And if you see Heather or any reference to Heather in the second equation, you're not going to use H for Heather. What are you going to use? Now you're going to use H plus 6. All right, so it says in 6 years, he. Who's he? Pete. And how do we represent Pete? In 6 years, P plus 6. So Pete will be equals. Right? Remember that is, will be, or was all mean equals. 4 times as old as she. Okay? So what about 4? How do we write 4? Oh, Ryan? What do we put for 4?
Sorry.
What do we put for 4? Just
So, times H, or H.
yeah, put the number 4. Okay?
You're on the right track, Ryan. Remember, we're talking about in the future now, right? So we're talking about Heather in the future. What's Heather in the future?
Older.
Look at the board. How are we going to represent Heather in the future?
Row 2 is the future.
H plus 6.
Yes.
Perfect.
And just remember, anytime we fill in for somebody's age in the future, we're usually going to have a distributive property. So we're going to put H plus 6. All right, so that's he will be 4 times and then Heather. All right, so those are all the important things. All right, now in this second equation, right now we've got 2 letters. Who can tell me which letter can I plug something in for using the first equation? Can I fill in something for H or can I fill in something for P?
P.
Yeah. What are you going to fill in for P?
5 times H.
Yeah. From the first equation, we know P equals 5 times H. So in the second equation, change P to 5 times H. Sam, can you tell me what this second equation will be after we substitute in for P? 5h plus 6, yep. Okay, so Sam did the distributive property at the same time. That's perfect. Okay, I'm going to write what she said as a second step. 5h plus 6. She said 4h plus 24. And if you want to do that, jump right to that step, that's fine. All right. Now we got to put all the letters on one side, put all our numbers on the other. What do you want to move first? How about Maria? You want to move the numbers with the letters or just the numbers? Just the numbers? Okay. What number do you want to move and how do you want to move it? Good. So she's going to move the 6 and she said subtract. So I've got 5h equals 4h, 24 minus 6, 18. And I like the way she did that. The way she did it, it kept this number positive. Okay. So she moved the number and she moved it exactly the way I would have. This is a box, the box right below the table. Okay, now we just, one step left. Okay, what's my last step?
Subtract 4h from 5h.
Subtract.
Both sides.
Yep, subtract the 4h from both sides. 5h, take away 4h, leaves me with how many h's? So what do we have on the left-hand side? Yep, just h. And on the right-hand side, 18. Okay, so now we know one person's age. Okay. Who was H again? Who did that stand for? Heather. Okay. So Heather is 18. Now, how do I find Pete? How do I find Pete's age? Oh, Victor? All right. Anybody help Victor out? How do we get Pete's age? Kevin, you think you know? We've got to use an equation we have up on the board. Do you think it would make more sense to use the equation in row 1 or the equation in row 2?
Row 1.
Yeah, I like the equation in row 1. Let's write that down. And which one of those letters do we know? Did we just solve for P? Yeah, what did we say H was?
18.
H is 18. Okay, so I'm going to fill in 18, okay, for H. And now if I do 5 times 18, I will know the age.
90.
Yeah, yep, 90. Okay, any questions on that one? Yep, scroll up a little.
Guys, if you don't need to get any of that down, for example 3, the one with Leah and Walt, can you guys so obviously we're gonna go over it together, but can you guys just set up? Can you do the subject line? And I want you to set up the variables in the equation. So the row with the names or the subject, and then the row with the variable. Just set up those 2 things.
Does everybody have this so I can put it on the board so people can see it? Okay, and as you go through this one, look at it carefully. It's similar to what we did, but does anybody see the big difference?
It's subtraction instead of adding.
Yeah. We're talking about ages in the past now. Okay, how old somebody used to be, not how old somebody will be. Yeah?
Wait, so is the answer going to be negative now since it's not?
No, their ages should still be positive. Yep. Yep, still going to have positive ages. Okay, since we got about 10 minutes, we'll just start to go through it a little bit. Justin, what are the names of the two people?
Yeah.
Yep. Leah and Walt. Okay, at least we know the names of the people we're working with.
Will you get this on the test? So you said it's going to be set up like this, right?
Yes.
So will you get some credit if you do like the name, the single variable, and the equations?
So the way I'm going to do it, there's 4 things I'm going to look for in every problem. Okay, 1, I'm going to look for, did you get the right first equation? Did you get the right second equation? And then did you get Leah's age? And did you get Walt's age? So those are the 4 things I'm going to look for.
Okay.
So to get partial credit, you at least have to set up the equation correct. You don't have to solve it to get, you don't have to be able to solve it right away, but you will get partial credit just for setting up the equation. Then to get full credit, you have to solve the equation. All right, single variable for Leah. L. Just to avoid it looking like a 1, I'm going to use a capital L. For Walt, I'm going to use W. And now let's look at our heading for row 2. 12 years ago. So 12 years ago, is that the future or is that the past? Past. So what operation do we think of when we think past? Subtract. And we're talking about how many years ago? 12. So now in both of these columns, just write Leah's age minus 12, Walt's age minus 12. Okay. L is how old Leah is now. W is how old Walt is now. L minus 12 is how old Leah was 12 years ago. W minus 12 is how old Walt was 12 years ago. So in the first sentence, you're going to stick with the letters in the first column. In the second sentence, when we get to it, we'll use the letters in the second column. All right, so let's start with the first column. Leah is. Okay, how would you write Leah is? Victor?
L equals
Yep. L, and you already got the equal sign.
age 12.
8 years younger. So what operation do we think of? Subtract. And now we got to be careful about the order. How would you write 8 years younger than Walt?
8 minus
That'd be Walt years younger than 8. Yeah, that wouldn't make sense that way. So think of Walt's age decreased by 8. Think of it that way. Justin?
W minus 8.
Yeah, put the letter first.
Yeah, guys, when you get to that part for that first equation, the row 1 equation, always put the letter first. All right? Whether it's addition or subtraction, always put the letter first.
Now, in the second sentence, this is the one about the past. So 12 years ago, first important thing I see is Walt. How am I going to represent Walt in the second equation? W minus 12. Walt was. What did we say? Is, was, will be. They all mean equal. Walt was twice. Okay, what number do you write down for twice? 2. Twice as old as who? Walt was twice as old as Ben?
As Leah,
Leah. And how do you represent Leah?
L minus 12.
Good job. Okay, so you guys are doing good. First equation, use your letters in the first column. Second equation, you got to use the letters in the second column. All right? And now, from here, we're going to take what we got for L, W minus 8, and we're going to fill it in for L. Okay, I'll finish solving up for L, and I think that's the last thing we'll be able to do. So, W minus 12 equals 2, and now in parentheses, L minus 12. Okay, fill in W minus 8. That's L, and then you still have the minus 12. This time we have a little arithmetic we need to do in the parentheses first. Negative 8 take away 12 is negative 20. And now, what am I going to do with the 2? I'm going to distribute. W minus 12, 2 times W, 2 times negative 40. All right, let's see what happens. We hope we don't get a negative for W. I don't think we will. What I'm going to do is I'm going to move the W to the right. I like to keep the W's positive if I can.
And you move the smaller one.
What's 2W take away 1W?
How many W's are left?
Yeah, just W.
If you put one W, you're not wrong.
Now I'm going to move the 40 to the other side. Okay, 40 take away 12 gives me 28. Right. So now I know Walt's age. I would have to go and plug that back in to find Leah's age. And if you did it out, it would come out to 20. Was it Leah or was it? It would be 20. $40 take away 12 is 28. All right, so for homework, we're not going to give you guys many problems. I think it's like 4 or 5. Four problems.
Guys, do us a favor. Don't lose that note sheet. Because we didn't get to number 4. We'll do number 4 tomorrow as a warm-up. So don't lose those notes.
Okay, and for tonight, just worksheet 12.7. And this is the first of 2 sections we're doing this week.
Yeah.
Okay, next section we're going to spend 2 days on.